Here is your review for Learn Target 1.1 moles and molar mass. So one of the most common things you're going to do, something that I need you to be able to do incredibly quickly, is to know how to go between grams and moles and then particles. All right, when I say particles, this could be number of atoms, or sorry, let's start with number of molecules. So if we have CO2, how many CO2s are in our sample? It also could then, from there, we could ask you to go to the number of atoms. All right, so there's some pretty simple calculations. You can use dimensional analysis, you can use a formula, you can use proportions. I'm going to kind of show you all three, and you kind of figure out which one you want to use the best. So another thing we've got in here, Avogadro's number. So you've seen this number before in first year chem, or I'm just going to start calling it JV Chem. We referred to it, we just did 6.02 times 10 to the 23rd. Now it's 6.022 times 10 to the 23rd, and you'll notice this unit moles to the -1. All that means is something per mole. So for every 1 mole, you have 6.02 times 10 to the 23rd something. That something could be molecules, it could be atoms, usually it's going to be molecules, or particles. Particles is kind of our catch-all for individual units of atoms or molecules. So you will be provided that number. It'll always be on an equation sheet that you will be given, so you do not need to memorize that number. You just need to know how and when to use it. So here we go. All right, so first of all, the mole. Some students get all the way through chemistry and they still don't understand what the heck a mole is. So if you are having trouble understanding that idea, go ahead and watch that video. It's not very long. All right, so first I want to talk about the difference between the number. When I say number, I mean number of particles, so how many things you have, and I know physics will hate me when I say this, but I'm going to go for it anyway, how heavy it is, or how much stuff there actually is. So those are the difference between the number of particles and the mass. The mass is measured in grams. We can only measure that on a scale. The number of particles is like the individual counting of how many atoms or molecules we have. So here is an equation that is available for you on your equation sheet. We haven't really used it in JV Chem. We really pushed you toward dimensional analysis. And again, you can do it either way. So the equation is N is equal to M divided by capital M, and actually many times on the equation sheet this is just a fancy looking M. So this is the number of moles is equal to the mass of the sample divided by the molar mass of the sample. All right, so first of all, we've got to remember how to calculate the molar mass of a sample, because you're going to be doing that. You're actually not going to need to calculate it too many times, but you might have to calculate it sometimes. So here we go. Here's the periodic table you're going to be given. Again, you'll be given this and the equation sheet on every single assessment. First of all, you might notice on that periodic table that it's only the symbols, it is not the names. Whenever you need to use this, you will be given a chemical formula. You do not need to take something like iron 2 chloride and then figure out what the chemical formula of iron is. Chloride, you'll actually be given FeCl2. So, and sometimes you're given the molar mass. So let's say if we are working with water and you needed to figure out the molar mass of water, you would, if you look at the chemical formula of water, you can see it says H2. So again, what that means, and again, these subscripts, this is also review, you need to recognize those subscripts are telling you how many of each of those atoms or each of the elements you have in the formula. That is another thing that is going to be pretty common for you to need to recognize, because many times when these molecules, or more likely the ionic compounds, dissolve in water, the ions are not attached to each other, so you need to know how many individual ions you have. So if we needed to figure out the molar mass of H2O, you see I have 2 hydrogens. So I would have my hydrogen is 2 times 1.008, and then my oxygen only one of them, and then oxygen is 16.00. I plug that in. And of course, you will always have access to a calculator. It used to be in AP Chem that there were calculations that you would need to do without a calculator. They have started, this is the second year that you do not need that, so you will always have a calculator. So I plug this in and I get 18.016, but because of sig figs here, I'm going to round this to 18.02, and that is grams per mole. All right, so what that means is for every 1 mole of H2O, there are 18.02 grams. All right, so that's whenever you have something that slash symbol, grams per mole, grams per milliliter. It's really just a ratio of the grams and the moles in this case. Okay, so let's jump right into a review problem. How many moles of lead to iodide? So you notice right away, like I said earlier, we're going to give you the chemical formula. It's not just going to be lead to iodide and you have to figure it out. You're actually going to get PbI2. Are there in a 25-gram sample? So again, here's my pile of PbI2. I will need the molar mass of this. So looking back at my table, my molar mass, I have lead, the heck is Pb, there it is, 27.2, and then I have 2 iodines, I guess I should say 2 iodides, because these are ions. And of course the reason I know that they are ions is because this is an ionic compound. I have a metal, lead is a metal, and I have a non-metal. Again, as I'm doing these short little videos, I'm going to kind of throw back to a whole bunch of little things that you need to know. So you do need to recognize, not for this particular problem, but just in general, whether you have an ionic or a covalent compound. All right, so I get that molar mass. And it ends up to be 461, but again, you want to be careful. I've got 1 sig fig there, so I'm just going to plug that in again because that just seems kind of strange, but I guess it makes sense because 0.9 times 2 is going to be 1.8 plus 2, so that makes sense. So that many grams per mole. Okay, all right, so now again, I'm going for moles. Again, you need to recognize, okay, is it asking for moles, particles, atoms, what is it? So this one, I just need to go to moles. So here's the most common thing you're going to do, the way we taught it in JV Chem, 25.0 grams of PbI2. Again, you don't need that one. 46.01 grams, 1 mole, PbI2. And then I would just simply solve that. So 25 divided by the molar mass. And again, as I'm doing these, I always want to think about sig figs. Usually in your assessments, we're not going to check sig figs for every single problem, but you want to get in the habit of, there's a reason why we write numbers the way we do, and that's to represent how accurate the information is. So 0.0542, in this case, this is moles of PbI2. Okay, so like I mentioned earlier, there's a couple different ways to do it. I could have used the formula right here. Number of moles is equal to mass divided by molar mass. So let me just put that over here. N is equal to mass divided by molar mass. So 25.0 grams divided by the molar mass, 461.0. You notice mathematically, I'm going to end up doing the same thing, 25 divided by 461, and that works. So I'm going to get the same answer. Again, I don't care which way you do it. All right. Next question, how many atoms of lead are in the sample? Okay, so right now, we know how many moles of PbI2 we have. Remember, a mole, let me get out of that red because that looks a little jarring. One mole of, in this case, we are, again, I can have a mole of anything. In this case, I have a mole of PbI2. That means I have 6.022 times 10 to the 23rd particles or molecules. I'm going to go with particles. I'm going to probably use particles whenever we're talking about a compound. So I know how many particles. So again, here, this is one particle, what I've drawn here. Again, it's not to scale, but this is one particle of PbI2. There's one Pb, there's two I's, they happen to be ions. So that's one particle, PbI2. This is asking for atoms of lead. So I'm going to need to go from my number of moles, 0.0542 moles of PbI2, get that into how many particles that actually is. So 1 mole, again, of anything, in this case PbI2, is equal to 6.02 times 10 to the 23rd particles of PbI2. Then I want atoms of lead. So now I have to look at this formula, or look at my model of formula, either one, and see, okay, for every one particle of PbI2, there is one atom of lead. All right, if it had asked me for atoms of iodine, then it would be 2 atoms of iodine for every one particle. So again, I'm just basically taking this apart, and since now I have a one-to-one relation for every one particle, I'm just going to abbreviate that part, PbI2, there is 1 atom of lead. And then I'm going to solve that. And, you know, you do, and the question's going to come up, do I really have to show this step? Yes, yes, yes. You need to communicate. You can't just, as some of my students who had me in their first chem year will recall last year, one of my favorite sayings is, you can't just be brilliant, you have to communicate brilliant. So you need to show that you understand that, oh, it just in your head, yeah, it's the same number, but you need evidence as to why it's the same number. So you do need this step, absolutely. If you drop that step off, I don't know that you understand the difference. Like, you can say, oh yes, Mom, you know, I'm smart. Well, you need to communicate that. 3.27 times 10 to the 22nd. And that is atoms of lead. Okay. All right, so this problem really walks us through a whole bunch of the things that you need to know for 1.1. You need to know how to find molar mass. You need to know how to convert between grams and moles, between moles and molecules, between particles, and particles to atoms. Okay, so I'm going to recommend that you pause the video, try this one on your own, and then start the video up again and see how you did. All right, so we're going for mass. So mass is always going to be in grams. And we're starting with particles of water. So particles of water, how many of these do we have? How many H2O particles do we actually have? So 2.30 times 10 to the 24th particles of water. Okay, so I can't go directly to grams, because here's the thing, again, on the periodic table, that we had this number earlier, this 18.02 grams, that is equal to, grams of water, that is equal to 1 mole of water. All right, so we're not in moles yet, so that's the first thing I have to do. I have to get into moles of H2O. 6.022 times 10 to the 23rd particles. Again, those cancel out. Now I know for every 1 mole of H2O, there are 18.02 grams, and then that's all I need to do. So another thing you're going to need to review is how to enter scientific notation into your calculator. Again, I will have, those of you who had me last year, I will have those house calculators that you can borrow. Sorry, I'm struggling to talk and type at the same time. But again, you can also, many of you have your TI-84s, you can also use those. So, looking at sig figs, the calculator, I've got 68 looks like I'm going to go with 3 sig figs here, so 68.8 grams of H2O. There we go. Okay, so again, mass is always going to be in grams. If you see mass of something and you're coming from grams, you're going to need that mass on the periodic table. Excuse me, if you see mass, you're coming from particles or atoms. Usually we're coming from particles, you're going to need the mass in the periodic table, or the molar mass. All right, so here is a different style of question. Given 10.0 gram samples of LiCl, or lithium chloride, lithium bromide, lithium fluoride, and lithium iodide, that's what this is. I should have used a font that showed that. Place the samples in order from least to greatest number of atoms of lithium. All right, so here's the first kind of major difference between what you did in JV Chem and what you're going to do in Varsity Chem. So again, the learning target, you might not have noticed that. The learning target, calculate quantities of substances, its relative number of particles using dimensional analysis and the mole concept. It's much more vague, and there's many more ways we can ask you to apply this. This is why it's AP. It's our second year. We're going to expect you to do a lot more. You need to be able to look at the question, break it down, and say, okay, what does this have to do with? How do I do this? And that is a little more challenging. But it's AP, it's Varsity Chem. Okay, so a couple different ways you can do it. One, I would suggest turn off the video, work on it. See if you can figure out how to do it. You don't actually have to calculate it. You can. You definitely could calculate each of them. You also could start to look at these four things, see what's the same about them, see what's different, and see if you can reason your way through greatest to least. Again, it doesn't ask for any evidence. It just says to put them in order. So there actually is no, you don't need to give any reasoning, any mathematical support for it. You could just kind of reason it through. So, all right, so let's just stop the video and see what you can do. And I'll show you one way, the kind of first thing that came into my head as I was looking at it. All right, first thing comes in my head is noticing what's the same. So they all have Li in them. You're going to see a lot of problems like this. So this kind of next level or another level of thinking is going to be good. So that Li is all the same. Well, then what's different is the anion. Remember the anion, again, it's an ionic compound because lithium is on the left side of the periodic table. The anion, all four of these anions are in the same row the same column or the same family in the periodic table, which makes sense because the ratio of each one of them is 1 to 1. And that's the only way it's going to happen. So what I can do is I'm going to look at them on the periodic table. Fluorine is on the top. Then I've got chlorine. Then I've got bromine. Then I've got iodine. All right, and I'm just going to jot the numbers down, and the numbers, the masses, go from smallest to greatest. This is really going to help us out. And some of you might already have the answer, and other people are like, I need to go a little bit further. Okay, the least number to the greatest number of lithium. All right, so I have 10 grams of each of these samples. So kind of the way you might just be able to reason through and might be confident. I'm actually going to show you the math behind it. So what I would do is I would say if I have 10.0 grams of something, I'm going to start with LiF. So I know it's either going to go this way or it's going to go this way. It's the only way it can go. I can't put them in any other order than from the top to the bottom of the bottom of the top. All right, so here's how I would calculate if I actually wanted to know what it was. I would take that gram number, and then I would take it divided by the molar mass of whatever I have, in this case, LiF. All right, and that would get me to, so that would be grams, that would get me to 1 mole of LiF, and I'm trying to go for atoms of lithium. So for every 1 mole of LiF, 6.022 times 10 to the 23rd particles, and then that's of LiF, and for every 1 particle of LiF, there is 1 atom of lithium. Okay, so again, the only number we're changing is right here. So let's put the small number in. So if I put 19.9 in, I'm going to get a certain answer. And then think about how it would be different is if you put this is just going to be the smallest value. This is going to be the largest value. The reason I stopped is because it's not just 19, it's really 19 plus lithium itself is 6.94, and so I'd have to add those together. So it'd be something on the order of 25-ish. So I'm just going to write in 25. Again, since it's not asking me for numbers, I can just estimate these things. The largest one would be, what, about 133? doesn't even matter. Okay, so I'm trying to figure out which one is going to give me the largest answer and which one is going to be the smallest answer. 10 divided by 25 versus 10 divided by 133. All right, so the one that is going to give me the largest answer is going to be this one. The one that gives me the smallest answer is going to be the largest mass. So to put, then again, if you want to, go ahead, plug all the numbers in. But then I want you to come back and think about that number reasoning. Because again, you can definitely put all the numbers in, but that's also going to slow you down. But there's no problem with that. So, but I also want you now starting to think about, okay, I just sometimes need to find patterns. I don't actually need to know the amount of the answer. I just need to know how they relate to each other. And some of you are going to be like, yes, this is what I've been waiting for. I can just, show how quickly I can figure this out. All right, so it says from the least to the greatest, so the least one is going to be LIF. And then the next least, LICL, LIBR, and LII. All right, and that is your summary of 1.1. All right, so you can start working on the practice problems again in the homework. In order for the homework to be considered fully completed, or to be receiving full credit for the homework, you need to do at least one problem under each learning target. That problem, of course, contains, if there's multiple parts, A, B, C, and D, you do need to do all of them. But only do, I definitely want you to do one of each, see how you're doing with it, and then you can always do more if you feel like you need more practice.